Erlenmeyer Azlactone synthesis. In this method, we can prepare the alpha amino acid by heating an aromatic aldehyde with hippuric acid. So first thing we have to remember for this Erlenmeyer Azlactone synthesis is that कि ये जो reaction है that is between the aromatic aldehyde plus hippuric acid, that is between the aromatic aldehyde and the hippuric acid. So we required initially the two things. One is the aromatic aldehyde and second one is the hippuric acid. So this is when we heat these aromatic aldehyde and hippuric acid, we get a very important thing that is known as lactone. That is known as lactone. So from this as lactone we get the alpha amino acid. So let's start the preparation of alpha amino acid by using aromatic aldehyde and the hippuric acid. So first of all, let's see, let's take one of the aromatic aldehyde. Suppose if we take the benzaldehyde, this is the benzaldehyde is C6H5 CH double bond O, that is benzaldehyde. First requirement is aromatic aldehyde and second thing जो requirement है that is hippuric acid. And what is this hippuric acid is? This is known as hippuric acid. So this is hippuric acid is there and we have aromatic aldehyde is there. So what happened when they react with each other in presence of acetic anhydride? अगर जब ये acetic anhydride के presence में इनका reaction होगा, so we are taking acetic anhydride for the reaction. First thing, so what happened? This O and this H2, it will lost. तो यहाँ क्या निकल जाएगा? Because we are using the acetic anhydride, और acetic anhydride का क्या role है? This is a dehydrating agent. ये क्या है? Dehydration करेगा यहाँ पर. तो dehydration करेगा तो ये जो hippuric acid का H2 and aromatic aldehyde का oxygen remove हो जाएगा. So we lost this H2O molecule from here, and then after losing this, then we get this type of a structure. We get C6H5 CH double bond, that is now this part is there, CH double bond यहाँ रह जाएगा और ये किससे कनेक्ट हो जाएगा? इस वाले कार्बन से, and COOH is there and we have this NH C double bond O C6H5 is there. Then it reacts with CH3 COONA, that is sodium acetate. It reacts with sodium acetate, and sodium acetate का क्या role है? That will act as that abstract a proton, तो यहाँ क्या होगा? जो ये H है, that will be abstracted from by using this CH3CO minus sodium acetate, and this abstracted proton will taken by this oxygen atom. So finally we get this C6 H5 CH double bond C COOH, that is acid group, and this is converted into N डबल बॉन्ड, बिकॉज जब ये H निकलेगा तो यहाँ पर से नाइट्रोजन और कार्बन के बीच में क्या बन जाएगा, एक डबल बॉन्ड बन जाएगा, एंड that will convert it into like this will change into like this. So this O that is converted into the OH, that will convert it into OH. Now there is a removal of water molecule from here, so this will be the negative and this will positive, and what happened, this H and this OH is removed here. जब ये यहाँ से निकल जाएगा तो we get this type of structure again. We get a cyclic product, and that is C6H5 CH double bond C, and this is the C double bond O, and this is N double bond C C6 H5 and this oxygen atom. So this particular formation is known as azlactone. This is known as azlactone. तो सबसे पहले हमारा जो काम था, जो बनाना था, that is preparation of azlactone. तो यहाँ इसका synthesis हो गया by using this aromatic aldehyde. First step में we are using this aldehyde aromatic reacting with the hippuric acid, and then finally we get this azlactone. After formation of this azlactone, this azlactone is react with 1% NaOH solution. React with 1% NaOH solution, and this NaOH solution is required to break this azlactone ring. This is the azlactone ring because this part is a lactone, and because due to presence of this nitrogen, this is azlactone, and we are using the 1% NaOH. We are using 1% NaOH to break this ring, to break this azlactone ring. When we are using this, then this ring will break like this. तो यहाँ पर क्या होगा, ये so because now this bond is broken up, ये bond यहाँ से टूट जाएगा, तो electrons will shift it over this oxygen atom. So जब क्या होगा, यहाँ पर ऑक्सीजन पे नेगेटिव चार्ज आ जाएगा, और जब इलेक्ट्रॉन्स यहाँ से इस बॉन्ड से शिफ्ट हुए ऑक्सीजन के ऊपर, तो दिस कार्बन विल गेट द पॉजिटिव चार्ज. सो व्हेन OH minus and H plus is there, because we are first step we are using the 1% NaOH, and then we are doing this hydrolysis also. So this OH will go to this carbon, and this H plus will go to this oxygen atom. So when these are going on their places, so we get C6 H5 CH double bond C, and again we get this acidic group again, COHS group is again, and then it will change into N double bond C, that is C6 H5, and we have this OH. तो यहाँ पर जब ये OH यहाँ से जुड़ेगा तो ये वाला पार्ट किस में कन्वर्ट हो गया, this part will convert it into acid group, and इस ऑक्सीजन पे जब ये हाइड्रोजन जाएगा तो that will convert it into OH. So this is converted again into acid, and this is again converted into OH. that is the same structure as that is this. ये जो बना था सेम स्ट्रक्चर फिर दोबारा बनता है इसके अंदर, and now it is tetramerized. that is the tetramer इसका बनेगा tetramerizes, and so this will formed C6H5CH double bond COH, and due to tetramerization this will convert it into NHC double bond O C6H5, because due to tetramerization this hydrogen will go to this nitrogen atom, and the electrons, this pi bond will break up like this. So this oxygen, this nitrogen will get the positive charge, negative charge, and this hydrogen will shift it to this nitrogen atom to form this NH bond, and the electrons which are present on this oxygen atom will go to form this double bond again. So this double bond between the carbon and the oxygen will formed. So we get again this amide functional group here, and now C6H5 will remain as such. So this part is formed. So for to convert any, to prepare any amino acids, the requirement is now full almost, because all amino acids required one acid group, and we have this NH group is also there. So next जो है वो we have to convert this NH into NH2 group so that it becomes the alpha amino acid. So how can we do? So now we do the reduction. इसका reduction करें. If we do the reduction, we have to do the reduction, and that is by the sodium amalgam. We do the reduction in sodium amalgam. So this is the reduction process. So when we are doing the reduction, what we'll get, इसका reduction हो जाएगा, तो ये जो unsaturation है between here, that will lost, and finally we get this type of a structure. So जब reduction करेंगे सोडियम अमलगम में, तो we get C6H5, and this will convert it into CH2, and unsaturation is lost, and now it is saturated. So now it is become CH, and that is COOH is the, and this part is remain as such. That will be NH C double bond O C6H5 is there. Now almost we have completed our preparation of amino acids. Now we have to remove this part. If we want to remove this part, हमें ये part को remove करना है, जिससे कि और इसको convert करना है into NH2 at the alpha carbon, इसको amino group में convert करना है, and that is done by hydrolysis. That can be done by hydrolysis in acidic medium. We are doing the hydrolysis, that is hydrolysis is doing in presence of acidic medium. When we are doing the hydrolysis, this bond is broken up from here. ये यहाँ से ये bond cleavage हो जाएगा. This will lost, and we get, what will we get? We get C6H5 CH2 CH C double bond OH, and now this NH is converted into NH2. So we have lots of this OH minus ions and H plus ions there. So suppose I write this OH minus ions here and H plus ions here. So when this bond is cleavage here, ये जब bond यहाँ से cleavage होगा, so the electrons will shift it over the nitrogen atom. So nitrogen will get this negative charge. So negative charge is there on nitrogen, and this carbon will get this positive charge when this bond is broken up, because the electrons of this bond, between the carbon and the nitrogen is taken away by the this nitrogen atom. So this has the negative charge, so this H plus ion will go to this NH group, and this OH is will go to this carbon group. So finally we get this NH2 group here, that is amino group is there, plus this is removed, so we get this C6H5, and that is COH, that is known as the benzoic acid. So we get this benzoic acid also with the preparation of alpha amino acid. So because now this is the C6H5CH2 group is there, ये जो group जुड़ा है, that is suppose this is the R group which is connected, and this is the alpha carbon. So NH2 is there, COH is there, so this is the alpha amino acid, and due to presence of C6H5CH2, this is known as phenylalanine. This is a preparation of phenylalanine. So we can prepare the aromatic alpha amino acid from this Erlenmeyer Azlactone synthesis. Now let's summarize this whole process. So उसको सारा summarize करते हैं कि कैसे क्या है. So first requirement is aromatic aldehyde, and that is react with the hippuric acid. So we can write, so first step, that is we have to use this benzaldehyde. We have to require this benzaldehyde, and that is react with hippuric acid. And when this benzaldehyde and hippuric acid is react with acetic anhydride, and this is react with acetic anhydride, that we get this azlactone. Azlactone synthesis is there, and when this azlactone is there, then this azlactone is get reduced by using sodium amalgam after tetramerization. So we do the reduction here, and then after reduction, then we do the hydrolysis. जो भी यहाँ product azlactone के बाद जो भी product बना, that is hydrolyzed. उसका hydrolysis हो जाएगा, and finally we get this aromatic alpha amino acids is prepared from this Erlenmeyer Azlactone synthesis.